guys, so for number 4, we have that at a running club, Sungjin conducts a test to determine if there is any association between an athlete's age and their best time taken to run 100 meters. So, depending on their age, are they better or worse off for running 100 meters? 8 athletes are chosen at random and their details are shown below. So just so that we understand, for example, athlete A is 13 years old and ran 100 meters in 13.4 seconds. Athlete E is 19 years old and ran the 100 meters in 12.0 seconds. So that is what this table is telling me. And of course, because it's IB, they tell us that Sungjin decides to calculate probably the nastiest buzzword you are ever going to hear, decides to calculate the Spearman's rank correlation coefficient for his set of data. And we need to complete the table of ranks for part 8. So, before I jump into how to do it, this or that, etc., a little bit of context. Spearman's rank correlation coefficient is a way in which you calculate, there it says, correlation. And so what the heck is correlation in the first place? Correlation is used in the real world because it helps you understand how two variables interact with each other. So for example, let's say that down here on X, I have, hours spent studying. And then on Y, I have your grades. Okay, and so clearly, if you spend more hours studying, and all these points are different students, okay, all the students in your class, the more you spend studying, the higher your grade is going to be. And so obviously the conclusion here is the more you study, the higher your grades are. Here, you have what we would call a positive correlation. It's a positive correlation because the more you spend studying, the higher your grade is. The higher X is, the higher your Y is going to be as well. That is a positive correlation. Okay, the higher your X, the higher your Y. There you have a positive correlation. Of course, you have the flip side, which is, maybe the higher your X, the lower your Y. And so you can have an example where you have something like this, where clearly the higher your X, the lower your Y is going to be. And this would actually be a negative correlation. Okay, so correlation is really, it just establishes the relationship between two variables. It's very useful in statistics. And so over here, one of the ways in which you calculate correlation is using Spearman's rank correlation coefficient. Now this is a massive buzzword, and I know it looks nasty, but the most important word, you guys, the most important word is rank. So what you're going to be doing here for part A when you complete the table of ranks is that you will be ranking your data. Quite literally, you will be ranking your data in order. Okay, this is essential, in order. And this table right here, maybe they do it as a reminder, maybe not, already put the age rank of athlete C as 3. And so that means he is the 3rd highest age. And for example, the time rank of athlete G is 1st. And so the highest time rank is athlete G, which makes sense because if you look up here, right, the equivalent, 17 seconds is the largest amount of seconds. That makes a little bit more sense, doesn't it? So Spearman's rank correlation coefficient helps you establish some sort of correlation. It might be positive, it might be negative. And in this case, we do it by ranking. So that's the key word, Spearman's rank correlation coefficient. You will be ranking your data in order. So let's go ahead and go piece by piece. Let's start with age. Okay, so with age, well, which athlete has the highest age? There's a 36 over here. It's pretty much a boomer. Just kidding, pretty much a boomer. This would be number 1. See? Which one is the most boomer? The one that's 36 years old. Who's the next boomer? Well, if you go down, or what's below 36, The next height will probably be one of the 20s. It's going to be the 25. So athlete F on 25 is going to be the second oldest. The third oldest is going to be this 22. I already put the third one right there. So following that logic, you can finish filling in this table. Just to go quickly, the next highest after 22 will be 19. Then it looks like it's going to be 18, then 17, then probably the 13, right? Yeah, 7, and the 11, the 8. We make sure we filled in each square. All good over here. So that is for age. For time, something interesting happens, and it might have been why you clicked on this video. It might be something you're trying to solve yourself. So the highest time is 17 seconds right there. The second highest time follows the same logic as for age. So which one is the second highest after 17? We scan. It's going to be athlete B with 14. So here's going to be my second. But for the third one, you notice it's athlete A with 13.4, but also athlete C with 13.4. And so for now, you guys, I need you to understand that athlete A and C, it's not that they're both third, it's not that they're both fourth, it's like they're between the third and the fourth place, okay? And for now, I'm going to leave it like that. I'll come back to how you should actually write it. But now just logically think about it like this. Your highest time was 17 seconds. Your second highest was 14.6. And your third highest is between athlete A and athlete C. So they're both sort of fighting for the third place, the fourth place. So how do you leave it as? For now, let's leave it as between 3 and 4. So that means that the next number that comes along, because it would be the fifth square that I'm filling in, is going to be the fifth highest. So the fifth highest after 13.4 is athlete H with 13.1. So over here we put a 5. Okay, it's very important I do that parentheses because since athlete A and C are between 3 and 4, the next square you fill in has to be 5. The other way you can think about it is that here you filled in one square, here was another square, here was a third square and a fourth square, so the fifth square has to say 5. Okay, it's very important you do that. A lot of people put 4 here and then things don't work out. Okay, so follow that logic. This is the fifth square you fill in, so I'm going to put number 5. Okay, yeah. Let's finish establishing the rest of the table. So after 13.1, the next highest seems like it's athlete D. So I'm going to put a 6 here. Then it's athlete E with 12. Then it's athlete F with 11.8. Now, I can't leave it as between 3 and 4 because the calculator is not going to like that. Because as you can see for part B, you need to calculate Spearman's rank relation coefficient. And so if you plug in between 3 and 4 into your calculator, it's not going to like it. You can't leave it as an interval. So what is between 3 and 4? Between 3 and 4, you have, whoops, spoilers. Between 3 and 4, you have 3.5. And so instead of putting between 3 and 4, you will be simply putting 3.5. All right? So there we completed the table of ranks. Very important, you follow the logic. It will always be the same logic. See? So once you identify your ranking, your data, it's certainly much more friendly. The one thing I've seen that they try to catch you with is this 3.5 thing. Follow the logic. Bear in mind how many squares you filled in. Make sure you put a 5 instead of a 4 here, and you're good to go. Okay? Yeah, so that is for part A. For part B, as I was saying, we need to calculate the Spearman's rank relation coefficient. So, how the heck do you calculate the Spearman's rank correlation coefficient? Obviously, you have to use your calculator because no one knows how to do this by hand. You can, but why would I show you that? So, in your calculator, because we're talking about a statistics problem, you should have established that already, you're going to be pressing the stat button. And you are calculating something. You're not testing something, you are calculating something. So you should be pressing stat and then searching into your calc tab. You know, like which of these should I use? And after scrolling for a bit, hopefully you eventually remember you have to use line reg. Okay, line reg, I need you to associate it to correlation. So I'm actually going to put up here as well, for positive correlation, for negative correlation, I need you to associate it in your brain, associate it to line reg. Okay, line reg helps you find correlations. And so if I go ahead and press line reg, well, what does it ask for? It asks for an X list and it asks for a Y list. And so notice, when this guy online told me that when X goes up and Y goes up means I have a positive correlation, that is why in line reg, they actually ask for an X list and a Y list. It's the two variables that you're comparing to see if they have a positive or negative correlation. So apparently I need to put it into my lists. So where do I find lists? Well, lists is right above the stat button. So actually you can just press stat and then press edit. Here I put them already, but let me erase it and show you how to do it from 0. As you can see, L1 has to be your X. So we're just going to call this our L1. And our time will be our L2. Okay? So if I follow that logic, that age is L1 and time is L2, well, my L1 has to be 7, 6, 3, 5, 4, 4, 2, 8, 1. Okay, and then my line 2 is going to be the next row for the time rank. And so my line 2 is going to be 3.5, 2, 3.5, 6, 7, 8, 1, and 5. There's a very important detail here that we have to embark upon, which is the following. Notice how this 7 up here is associated to the 3.5. Notice how the 6 over there is associated to the 2. You have to be consistent. The 7 with the 3.5, the 6 with the 2, same with the 3 associated to the 3.5. That is essential, you guys. Spearman's is rank correlation coefficient. You need to rank your data and then make sure that they are aligned. Okay? So just keep that in mind. It's very important. Yeah? So double check on that. Once you realize it's all good over there, you can go back to stat, go to calc, go to line reg, make sure you put list 1, list 2, and then what the heck is this? See? What is my calculator doing? Do not freak out. Sometimes you can scroll all the way down to calculate, which means you didn't need the stuff in between. If you can press calculate, you didn't need to fill in what's before. Now, just so you know, frequency list is if you ever had a frequency list associated to this table, and store reg EQ helps you store it into your y equals over here if you ever want to graph it. We will never want to graph it because it's a waste of time, with all due respect. I mean, for our interests and purposes, we just need the value of RS. So we're going to go ahead and press calculate. You press calculate, it calculates. That's what a calculator does. And here you have a bunch of stuff. So Spearman's rank correlation coefficient is going to be the R at the bottom. Okay. And before writing down my answer, some of you, I'm sure there's some of you watching this right now, telling themselves, my calculator's glitched. Maybe you already wrote a comment in the comment section, who knows? And you're saying, why doesn't my R value appear? Do I need to update my calculator? What's going on? What's wrong? Nothing's wrong. It's just that you missed a small detail. You have to press mode and make sure that stack diagnostics is on. If stack diagnostics is off, and you follow the same procedure, you will come to realize that your R value does not appear. I'll be honest, I'm not sure why this is a thing. I think you should just always leave it on. The more information, the better. Am I not right? So make sure stack diagnostics is on. That should let you see the R value, okay? So that just a small detail. I'm sure someone out there needed it. There you go. So the R value for part B, so RS, notice you have one that is squared and one that is not squared. our answer is going to be the one that is not squared. Okay, so clearly it's going to be negative 0.670, 670. If you want to leave it as significant figures, you would be counting 1, 2, 3 after the 0. And this number, do you round it up or keep it the same? You round it up. And so significant figures, if you want, would be negative 0.671. Okay? So that is for part B. For part C, we now need to interpret the value of Rs in the context of the question. And so this is a very easy 1 point. It's really like a context question. I mean, it's literally telling us that, see? And I already gave you the tools for it. Remember up here how I told you that a positive correlation is one that, well, goes up like this, and a negative correlation is one that goes down like that. Well, quick pop quiz. The positive correlation, what slope does it have? You don't know the exact slope, but you know that the slope has to be positive. And the slope down here for negative correlation, what slope does it have? You're not sure, but you know that it has to be negative. Okay? So if you got an R value that is negative, then the slope is negative. Okay? Maybe the other thing that can help you understand this a little bit better is that technically, okay, you have two scenarios, right? Technically, this is X, this is Y, this is X, this is Y. So you have two scenarios. One scenario is a perfect positive correlation. And your other scenario is a perfect negative correlation. Okay, and in the perfect positive correlation, you have a line that goes like this, and your R value here actually equals 1. Okay, for every X value that you increase here, you increase one Y value, so on and so forth. All of these increase by 1. So that would be a perfect positive correlation. For a perfect negative correlation, you can probably already guess it. It would go like this. So your R value, instead of being 1, is actually going to be negative 1. Okay? So that means my X values here, like for example, an X of 1 will give me a Y of negative 1. An X of 2 will give me a Y of negative 2. So on and so forth. So a perfect negative correlation is R equals negative 1, while a perfect correlation is R equals 1. So whenever people are wondering, should I call this a strong correlation or a weak correlation? It depends on how close you are to 1. But notice how close you are to positive 1 or negative 1. And so the essential thing that you have to mention here is if your correlation is positive or if it's negative. Whether it's weak or strong or etc. is like, it's not as important as mentioning whether it's positive or negative. Okay? So down here, back to reality for part C, interpreting the value of Rs, we would be saying that it has a negative correlation, right? If you want to get fancy, you could say it has a relatively strong negative correlation because, well, it's negative. It's closer to negative 1 than it is to 0, so you can say relatively strong. Okay, fine. But the main point you're going to be getting is by saying it's negative correlation, right? Now, you're not done yet because this is a context question, so you have to connect it to the context of the problem. So in this case, you would actually say, let's remember the context of the problem. Sungjin, what was he doing in the first place? He was comparing athlete's age to the best time taken to run. So you can say that an athlete's age has a relatively strong negative correlation in respect to the time taken to run. Okay? So notice how I started off by writing the essentials. I started off by writing the essential negative correlation. Then just to secure the point, I got kind of fancy by saying the relatively strong part, see? And the other essential, which has to do with context, is that I connected the athlete age to the time taken to run. All right, so that is how you approach these problems. There's always a procedure that you can follow. If you learn all the procedures, you're gonna do just fine. Is that it? Yeah, so for part C, well, I put it up there, so whatever. That is for part C. And last but not least, we have the monster of a problem, part D, which says, suggest a mathematical reason. Damn. Suggest a mathematical reason for why Sungjin may have decided not to use what? Not to use Pearson's product moment correlation coefficient with his data from the original table. Guys, part D is awfully specific. Like, I'll be honest, this is the kind of thing that you either know or don't know, period. Okay? Let me give you a little bit of context. So remember back in the day where I told you what correlation was, and I also told you that you associate it to line reg. The thing is, the way you calculate correlation comes in many different ways. There is more than one way to calculate correlation. So one of them is by ranking them in order. And the other one is basically like not ranking. Okay? I know that this is a very fancy buzzword. Pearson's product moment correlation and Spearman's rank correlation coefficient. I know this is stuff that is kind of hard to remember. Okay? So what I suggest is remember that for correlation, one of them is ranking in order, while the other one is simply not ranking. All right? And so that's the first thing we need to establish. There's more than one way to get correlation. One of them ranks your data, the other one doesn't. There's probably more tools out there in the statistics world, but for now, we will only focus on these two for our math level. One of them ranks them, the other one doesn't. So what could be a mathematical reason? Well, that's literally one of them, okay? My values have an ordinal sort of approach to them, maybe they don't. Now, there's a lot of reasons you can put here. This is worth only 1 point, and I'd rather just show you the answer key and like take the discussion from there, okay? But I do want to be insistent on the point, be organized in how you think about it, okay? We're talking about correlation. There's two ways to calculate it. One of them, in general, has a ranking associated to it, and the other one doesn't, okay? That's the main idea. Now, there's a couple of other differences that we will embark upon now. You remember it however you want to. These questions are usually worth 1 point, so you don't have to memorize everything I'm about to tell you, but you should memorize or learn 1 or 2 of them, okay? Make sure you get that point. It's a free point that you can actually answer without A, B, or C. Okay, A, B, or C are completely associated with each other, but part D is not. Okay, part D you can answer by itself. So it's a free point. They can even answer if you're running low on time. That it? So, what are the reasons? Let's jump into it. Here is the answer key. And here it tells you. Okay? Now, for now, don't look here. Okay? Because I feel like it's a lot of information. It can come at you very strongly. I made a mini sort of summary down here. Maybe you want to write it down. Maybe you don't. Up top, I don't know why I put pink on both. Up top, we have Pearson's. Okay, so for Pearson's, these are the main connections, right? Pearson's if your data is continuous. Spearman if your data is ordinal. So ordinal follows some sort of order. Pearson's if it's continuous. The other thing is that Pearson's is used if you have something that is normally distributed. Spearman's if it's not normally distributed. And another difference is Pearson's if you expect a linear relationship. Spearman's if you have something that's not necessarily a linear relationship. And the biggest thing that I suggest you should remember is that Pearson's has no outliers, while Spearman's can have outliers, okay? Now, the no outliers thing is basically that Pearson's has a lot of troubles with outliers. Like, if you use Pearson's while you have outliers, your R value is going to be pretty flawed, okay? But using Spearman's when you have outliers, it's not as bad, okay? It doesn't affect your result as much. So, those are the main things you can compare. Pearson's is continuous, Spearman is ordinal. Pearson's is normally distributed, Spearman's is not necessarily. Pearson's has a linear relationship, Spearman's is not necessarily. Pearson's has no outliers, Spearman's can have outliers more comfortably. So it's 4 main differences. Technically, they're written up here. For me, it's a little bit harder to explain it from there. That's why I made the mini summary down below. But you will notice that they touch upon the same thing. Okay. For example, there are outliers or extreme data. So that is why Sungjin might have avoided Pearson's product moment correlation, because since you have outliers and extreme data, Spearman says is going to be better. Okay. Now, I could go through each of these, but I think I'm just going to confuse you. I feel like this is the kind of thing that you should write down over here, right? Or you can draw like a small table, like comparing the two, right? You can put maybe, I don't know, on the one side you have Pearson's, on the other side you can have Spearman's, and then you start writing all the differences. So for Pearson's, you have continuous. Then on the other side you have ordinal. Over here you have normally distributed. On the other you have not normally distributed, etc. See? Linear relationship, not linear relationship, and no outlier, yes outlier. Okay? You can sort of define it however you want. You can remember it however you want. The main message I want to transmit to you is that you don't have to know all the differences. Usually knowing 1 or 2 for the day of the test is good enough, since it's usually just worth 1 point. So just giving one of these is good enough. Yeah? A little bit of a longer explanation at the end, but I'm sure it helped someone out there. So that was for you. Ladies and gentlemen, that is for number 4.